The communication between aircraft and ground is important to exchange significant information between aircraft, Airline Operation Control Center, AOC, and the Air Traffic Control Center, ATC. Prior to 1978, the flight crew used voice communication through VHF or HF voice radios to communicate with the ground stations. The crew communicated with geographically dispersed dedicated radio operator in the ground station for self-reporting of flight status and position. Then the digital messages will be delivered to airlines through teletype system. But for airlines, crew self-reporting precludes inaccuracies. In July 1978, Air Inc. designed and deployed the ACARS system, which helps to reduce the crew workload and also improves the data integrity. The function of the ACARS data protocol is to provide character-based data connectivity between an aircraft and any number of ground-based service providers and satellites with whom the aircraft operator has subscription relationships. With the help of ACARS, the aircraft can send or receive messages between aircraft and the ground stations. Transmitting data from ground to aircraft is called uplink. Transmitting data from aircraft to ground is called downlink. ACARS messages may be of three types based upon their content. First type is Air Traffic Control, ATC, messages. ATC messages include aircraft requests for clearances, ATC issue of clearances and instructions to aircraft. They are often used to deliver pre-departure, data link ATIS and en route oceanic clearances. Second type is Aeronautical Operational Control, AOC, and the third type is Airline Administrative Control, AAC. These AOC and AAC messages are used for communications between an aircraft and its base. These messages may be of standard form or as defined by users, but all must then meet at least the guidelines of ARINC Standard 618. For examples, the AOC and AAC message includes: Uplink messages includes flight plan, load sheet, fuel load sheet, weather, and NOTAM information during pre-departure. Significant weather change information will also be uplinked to aircraft from Operational Control Center during the flight en route phase. Downlink message includes both auto downlinks based on aircraft events or manual text messages from the crew. The UOM messages are one of the major ACARS downlink messages, which is triggered based on aircraft sensors, which explains the flight phase status along with other parameters like flight information, fuel on board, gross weight of the aircraft. Downlink message includes position messages, estimated time of arrival messages and any diversion details from aircraft, which helps in flight tracking. Downlink of spot weather observations from aircraft sensors, which helps in the understanding of upper weather to make the better decisions. Downlink of technical performance data, including automatically triggered exceedance, or abnormal aircraft system status information. Free text messages between Airline Operation Control Center and crew in the aircraft also be possible using ACARS. The ACARS was modeled using telex system, and its architecture is based on three main components. The first component is onboard aircraft equipments. The aircraft has different onboard aircraft equipment which supports the ACARS messaging. Each aircraft has management unit, MU, or communications management unit, CMU, which will interact with onboard systems that supply air-to-ground communications over VHF, satellite and HF media. The CMU is connected to the aircraft data bus and it can generate automatic messages based on events. Multi-Purpose Control and Display Unit, MCDU, or the Control Display Unit, CDU, is the interface between the crew and the ACARS, represented by a screen plus keyboard system, and allows the crew to communicate with the system. The crew can send or receive the messages with the help of MCDU. Printer. Most of the aircrafts are equipped with a printer. Their size will vary depending on aircraft equipment. For example, Boeing 747-400F aircrafts are equipped with 40-character wide printer. Meanwhile, Boeing 747-8F aircrafts are equipped with 80-character printer. Messages from the ground can be sent directly to the printer. Once sent to MCDU, then the flight crew can decide to print. Some equipments provide printer status information to the ground computers. Flight Management Computer, FMC, can also provide position report information to the ground for flight following. Data Management Unit, DMU, and Aircraft Condition and Monitoring System, ACMS, in the aircraft collects engine parameters, For engine trend monitoring purposes, it can also send warning reports or respond to uplink queries. Usually, these equipments will trigger engine takeoff and engine cruise reports. Centralized Maintenance Computer, CMC, and Flight Management System, FMS, are used to send DAMP, receive information via data link without requiring crew intervention. CMC collects the warning and failure information from all aircraft equipments. Second component is the service provider. A data link service provider, DSP, is responsible for the movement of messages via the radio link, usually to or from its own ground routing system. ACARS messages are transmitted using one of three possible data link methods: VHF or VDL, which is line of sight limited; SATCOM, which is not available in polar regions; HF or HFDL, which has been added especially for polar region communications. The main primary DSPs are RINC and SETA. Until quite recently, each part of the world was covered by a single DSP, but competitive offerings are now increasingly available. The third component is ground processing system. Ground system provision is the responsibility of either a participating ANSP or an aircraft operator. Aircraft operators often contract out the function to either DSP or to a separate service provider. Messages from aircraft, especially automatically generated ones, can be pre-configured according to message type so that they are automatically delivered to the appropriate recipient, just as ground-originated messages can be configured to reach the correct aircraft.